Welcome to Industrial PLC Applications. This video is the first in a pair of videos on the requirements analysis form. When a system is being designed, it is anticipated that things may change during the entire project from design and planning to installation and production phases. However, at every step along the way, changes are documented so that everybody involved is aware of the changes taking place and approves them. Furthermore, if and when things go wrong, there is a paper trail that can identify when decisions were made, the circumstances under which they were implemented, and who approved the changes. When you work in construction, you may hear someone say to start any project, focus on the end of the project. Now that seems counterintuitive. But in construction, long before the ground is broken or a single bucket of cement is poured, every project begins with a detailed plan, a common objective that everybody agrees to follow. Industrial PLC applications are no different. Programmers look at the desired end result the customer wants and develops a plan to be approved before writing a single line of logic. In this video, we're going to go over something called the Requirement Analysis Form, or the RAF for short. Basically, we're going to take you step by step to analyze a project and break it down so that there's a common format that everybody can agree on. As was mentioned before you write any logic, you have to completely understand what the machinery or process is supposed to do. Customers may have a detailed plan, or they may have a rough idea. It's your job to sort everything out and to codify the project's technical, functional, and program requirements and parameters, and then submit your assessment to the customer for verification and acceptance. After completing this video, you should be able to apply critical thinking by analyzing a project and breaking it down into a concise and informative analysis. You should be able to define a project's functionality. You should be able to list the project's requirements. You should be able to interpret and transform a project description into a logical list of requirements and objectives. And you should be able to apply the requirements to build a program and execute the program as per those requirements. Like any job, especially in construction, you always have to remember first things first. Be prepared. Know the job, know what you need, and have the right tools. Any job, construction or programming, starts with being prepared. You don't want to go up and down 10 stories because you forgot a part or a tool. Well, programming is the same. Start with knowing the job. Every project starts with a description, the big picture, the overview. Well, with PLC programming, it's no different. The project description is a statement, usually from the customer or owner or an engineer, and it has the expectations of how a system should operate, behave, and perform. In addition to behavior, the project description can include things like expected quality and coding standards, operational limits and constraints on the project system when in service. Only once the project description has been agreed to can the project requirements start to be developed. There are many facets of a project, so we begin by determining what the requirements are for that particular project. The project requirements, or more commonly just requirements, sets out the project details. Requirements help everyone involved in a project to come to a common understanding of what the finished project should include. With any project, whether it's construction or PLC programming, you need to know the requirements. Nobody wants to do the job twice or make a mistake and have to fix it. Therefore, the project requirements, just like a set of prints, must be precise and include every detail: system behavior and performance, quality and coding standards, regulatory codes, specific hardware, details of the operating environment and operational constraints. A lot of stuff, as well as deadlines, working conditions, and final expectations. All of that you have to find out. Furthermore, over the life of a project, the requirements can and often do change. Therefore, it is imperative that you do the following. Record the requirements on a list or table for quick reference. And, to keep track of changes, give each requirement a unique identifier. Finally, use your requirements table as the basis of a test, implementation, and verification plan, and a completion list. By doing this, you save yourself a lot of grief. You save on unnecessary mistakes, cost overruns, or project completion delays, legal and safety issues, arguments and payment disputes, but mostly is so that everyone on the project knows what's expected, accepted, and when the job is done. There are many specific requirements that must be addressed, and it can seem overwhelming. So for now, let's categorize them into 3 basic categories and focus on those. They are project functionality, project properties and parameters, and project technicalities. Although listed last, I like to start with the project technical properties first. This is where the programming details and specialty equipment or standards are listed. Maybe the customer prefers a Siemens PLC rather than an Allen Bradley PLC. Well, that means different software and programming and a different PLC. Without finding that out, you could invest a lot of time, money, and effort only to find it gets rejected. Here are some examples of some technical properties. Okay, so first of all, what programming language is the project to use? We've been using ladder logic. They may want function block, or they might want structured text, or they may think that you're a computer programmer, not realizing that its PLC is different. Important question get answered. Okay, what software does the customer have? We're using Connected Components Workbench. If they don't have that, then there's something that has to be overcome. Is the project for domestic use or international use? If it's for domestic use, we're following Canadian safety standards, we're following Canadian electrical code, we're following the Ontario, if it's an Ontario electrical code, etc. If it's going to be the States, that has to follow the national code, or if it's in Europe, that's a different kettle of fish again. Is there any specific pieces of equipment or brands the customer wants? Maybe they've had no luck with Allen Bradley products, for example, and they've gone a different direction. Or maybe they have specific proximity switches or limit switches that have to be used. Maybe it's an explosion proof. All of these pieces of information, you don't want to supply a regular limit switch and find out, oh, yeah, it's supposed to be explosion proof. Get these details sorted out first. They're quick and easy, and then you can move on to the next part. Okay, so now we can start looking at the functionality. What is the project supposed to do? So project functionality is the intended action or actions of the project and its programs. What is the project supposed to do? What events take place? What is the sequence of those events? And do those results of those events impact other events? The rule of thumb here is, if there's an output instruction involved, it's likely a functional requirement. Now we can look at the project properties and parameters. These are the defined variables used in the project. These include known or intended I/O assignments, variables you create, both global or local, timers and their preset values, and counters and their parameters, shared data, signals that you may be sending to another machine, and the assigned aliases. Okay, let's take an example of why we need to record these parameters and etc. Take a look at some timers. You have a project with 6 programs. Each program requires a TON timer. Each timer serves a different function and has a different set of parameters. They all have different time intervals. Without assigning an acceptable alias to each timer, you would have 6 TON_1s. Imagine the confusion during a breakdown. Or you copied and pasted them rung to rung and forgot to change the time. Chaos. Nothing but chaos. But we can list each timer as it's created, and the confusion never begins. In the example is the shutdown timer. It's a TOF, and we know exactly what the time is, 15 milliseconds. Furthermore, it provides the customer a way to customize and verify the results. Continuing on that theme, when programming, it is important that you understand and utilize any local descriptions or lexicon that may already be in use. There may be an operation where a person controls the operation or performs the work while the machine sits idle. You may call that manual control, but they call the same functionality hand control. When you create variables, you try to make them clear in your purpose and meaning, but it is more important that your customer understands the purpose and meaning and approves your choices. Like any other part of being a good tradesperson, planning makes your job easier and more efficient. With PLC programming, planning begins by analyzing the project and codifying the properties of the project that will save you effort in the long run. An RAF demonstrates that you understand the project and its parameters and technical requirements.